Today's topic is regression equations. A regression equation is an equation for estimating a dependent variable, say x1, from the independent variables x2 and x3, and is called a regression equation of x1 on x2 and x3. I repeat, a regression equation is an equation for estimating a dependent variable, say x1, from the independent variables, say x2 and x3, and is called a regression equation of x1 on x2 and x3. The procedure for studying multiple regression is similar to the one we have for simple regression, with the difference that the other variables are added in the regression equation. If there are three variables x1, x2 and x3, the multiple regression has the following form. x1 is equal to a 1.23 plus b 12.3 into x2 plus b 13.2 into x3. In the above equation, there are three constants, a 1.23, b 12.3 and b 13.2. The subscript after the dot indicates the variable which are held constant. If x2 and x3 are equal to 0, then x1 will be equal to a 1.23. In the above equation, b 12.3 indicates the slope of the regression. I repeat, b 12.3 indicates the slope of the regression. Line of x1 and x2 when x3 is held constant, and b 13.2 indicates the slope of regression of x1 and x3 when x2 is held constant. I repeat, b 12.3 is the slope of regression line of x1 and x2 where x3 is constant, and b 13.2 is the slope of regression of x1 and x3 with x2 held constant. Next, we will do interpretation of constants. A 1.23 is equal to the constant a 1.23 is the intercept made by the regression plane. It gives the value of dependent variable when all the independent variables are 0. A 1.23. It is the intercept made by the regression plane. It gives the value of the dependent variable when the independent variables are 0. B 13.2. It measures the amount by which a unit change in x3 is expected. So it measures the amount by which a unit change in x2 in x3 is expected to affect x1 when x2 is kept constant, and b 12.3 is equal to, it measures the amount by which a unit change takes place in x2 to affect x1 when x3 is kept constant. Due to the fact that x1 varies partially because of the variations in x2 and partially because of the variation in x3, we call B12.3 and B13.2 the partial regression coefficients. I repeat, due to the fact that x1 varies partially because of the variations in x2 and partially because of the variations in x3, we call B12.3 and B13.2 as partial regression coefficients. The next topic is normal equations for multiple regression equations. We know that in simple regression, there is a regression line approximating a set of n points x and y in a two-dimensional scatter diagram. Similarly, there exists a least square regression plane fitting a set of n points at x1, x2, x3 in three-dimensional scatter diagram. The regression plane of x1 on x2 and x3. x1 is equal to a 1.23 plus b 12.3 x2 plus b 13.2 x3. In the above equation, the values of B12.3 and B13.2 are determined by solving simultaneously the following three normal equations. The equations are summation x1 is equal to na 1.23 plus b 12.3 summation x2 plus b 13.2 summation x3. Next, summation x1 x2 is equal to a 1.23 summation x2 plus b 12.3 summation x2 square plus b 13.2 summation x2 x3, and summation x1 x3 which is equal to a 1.23 summation x3 plus b 12.3 summation x2 x3 plus b 13.2 summation x3 square. Let all these three equations be A. The last two of these three equations can be obtained if we multiply equation 1 by x2 and x3 on both sides. The regression equation of x2 on x1 and x3. x2 is equal to a 2.13 plus b 21.3 x1 plus b 23.1 x3. The normal equations for fitting the above equation are summation x2 is equal to n a 2.13 plus b 1.3 summation x1 plus b 3.1 summation x3. Then summation x1 x2 is equal to a 2.13 summation x1 plus b 1.3 summation x1 x3 plus b 3.1 summation x1 and x3, and summation x2 x3 is equal to a 2.13 summation x3 plus b 1.3 summation x1 x3 plus b 3.1 summation x3 square. All the above three equations are again termed as B. Now, the regression equation of x3 on x1 and x2 would be x3 is equal to a 3.12 plus b 1.2 x1 plus b 2.1 x2. The normal equations for fitting the above equation are summation x3 is equal to na 3.12 plus b 1.2 summation x1 plus b 2.1 summation x3. Summation x1 x3 is equal to a 3.12 summation x1 plus b 1.2 summation x1 square plus b 2.1 summation x1 x2, and summation x1 x3 is equal to a 3.12 summation x2 plus b 1.2 summation x1 x2 plus b 2.1 summation x2 square. Let the above three be equation C. So, generalizing the regression equation for more than 3 variables, x1 is equal to a 1.234 plus b 12.34 x2 plus b 13.24 x3 plus b 14.23 x4, and it goes on. The four normal equations for determining the values of a 1.234, b 13.24, b 12.24 and b 14.23 can be obtained by multiplying the above equations on both sides by x1, x2, x3, x4. This would give the multiple regression of x1 on x2, x3 and x4. I repeat, the four normal equations for determining the values of a 1.234, b 13.24, b 12.24 and b 14.23 can be obtained by multiplying the above equation on both sides by x1, x2, x3 and x4. This would give the multiple regression of x1 on x2, x3 and x4.